Hello there. This video is a follow-up of the previous video where we looked at batch arrival distributions with the Ciw Python package, and just a couple of things that I was reading about in the documentation that make sense but are worth mentioning. First of all, that for the batch arrival distributions, you need to pick discrete distributions. So it's fine to have deterministic values of, say, 3 like this. But if I had something like an exponential distribution with a rate of 3, I think this should give us problems. Yeah, so batch sizes must be positive integers. So I don't think that you technically need something that says that it is discrete, but if it happens to return values that are not equivalent to an integer, you are going to be in the doghouse with Ciw. Okay? And if you think about it, it makes sense. If you're talking about batches, we're talking about some finite collection, a discrete collection of things arriving. It kind of needs to be a count variable, right? A strictly positive value. Okay, that's the first thing that I wanted to come back to. And then the other thing is you can have multi-class distributions here. So if I break this apart into, say, there's class 0 arrivals, and then maybe let's just do 2 classes so I don't have to do so much typing. Class 1, and maybe they arrive at 10.5. And this needs to be a dictionary now. Yes, and then we have to basically break up, once you get into, distributions that are multi-class, you have to break all of this stuff out into the different classes. Let's say that that's every, oops, don't care about that. Every 6, perhaps. And for the last one here is the batch distribution sizes themselves. So let's say class 0 was what we had before. And then let's pick something else. Maybe a much larger batch of like 100. 100, that'll be exciting. And then the rest of this example should work as is. Let's just double check that that is in fact the case. Deterministic has no attribute length. Right. So for each class, you need to supply a list because it's 1 for every node. Right? So for a given class, you need to define the relevant distributions for each node in the network. In this network, there's only 1, but the structure of this API still requires that you provide a list. So we'll just quickly put some square brackets around there to tell Python that these are inside of lists. There we go. So we have some different arrival times now of, say, 10.5 instead of earlier it was the 18.5, because 10.5 just happens to be earlier and we simulated only for a certain amount of time. Now we can expand this out, like let's say we simulate for 100 units of time, then we should see really quite a lot more of multiple batches having arrived. Oh, I am mistaken for some reason. Why is that? 10. Go for a really long time. Okay, I'd have to think about why the spacing is not working the way I thought it would. Let's see, we got people arriving at 10.5. Oh no, I'm not mistaken. So we got the 10.5s, we got the 18s, we got some that are arriving at 21. Okay. I think that's fine. One of the things that becomes very possible in these discrete event simulations is simultaneous events, because they're all arriving simultaneously. And so if you have something like a mix of different customers that have different properties arriving at the same time, you can get simultaneous events. Ciw will handle that by randomly selecting things like who gets served next. If you've got, say, 5 different patients that arrive in a service and they all have different properties, but they're batched, so they arrived at the same time, how does Ciw know which one to pick? It will randomly select among them, which means that you don't have some kind of, pseudo-random state-dependent weirdness around, well, this particular combo for this seed always arrives in this order, and so that's how they get served type of thing. It helps break some of those symmetries. Okay, with that, I hope you found that to be a useful follow-up for the batching distributions for arrivals. And with that, I'll see you in the next video. Take care.